Hello, my name is Stéphane Gagnon. I'm an associate professor of information technology management at Université du Québec en Outaouais and Gatineau. And today I present about the future challenges in developing cybersecurity competencies. The topic we want to discuss today is the impact of cybersecurity challenges and what they represent in terms of work roles and competencies, and especially the capabilities that any organization is required to develop. The presentation will happen in two parts. The first part I will present on a competency framework that was recently released and also the aspect of situational awareness that are required in cybersecurity and response team. The second presentation is by a colleague, Marc Andre, postdoctoral student at École Polytechnique, whose doctoral thesis was focused on developing a cybersecurity competency ontology, which he thoroughly tested with different techniques for text annotation using the ontology. We will now present first the first presentation. My presentation will follow through the description of a recent competency framework called phane, as well as a discussion of cyber ops and the importance of cyber situational awareness and its value for automating incident response teams' work. First, a very recent publication by the MITR in Fort Meade, Maryland, as a contract that was performed for the NSA. The team at MITR developed a knowledge graph representation of a whole range of cybersecurity countermeasures and also linked them to attack scenarios. What we show here is an example of the scope of concepts that were integrated together around a single ontology, describing a full scale of the types of attack, but also the types of actions required to perform defense measures or countermeasures. This is an opportunity that is quite new in industry to reuse an openly accessible database in a graph format that can then be used to effectively search potential solutions, potential actions, given a certain number of cybersecurity conditions. And also in the same time can be used to assess the gaps that any organization faces in its operational capability. So this particular standard, not being the only one, but definitely the one that is the most advanced at this moment, at this state of the art, presents a major opportunity for, of course, for research in cybersec. And what we will do today is to discuss what kind of use we can make of such an asset or such knowledge graph. An example of application has been also recently done by the NSA with its partners CISA and the FBI, where the phane framework was used to annotate on the right-hand column here a set of defensive tactics and techniques in a particular type of attack classified as Chinese state-sponsored cyber actors attacks. And the reason for these annotations are quite obvious. When we search by keywords or even by certain sentences, or even if we use natural language processing, NLP, we end up having an unbalanced result. The search engines or the machine learning recommendations will not provide an entirely accurate depiction of the information presented. Meanwhile, if the annotations are used as the reference mechanism, because they are linked to one another and because they are fully integrated between attacks and defense mechanisms, they allow a more accurate and obviously a more reliable recommendation to be made based on the very specific items that they refer to, here numbered in blue after the number or index number within the graph database or the knowledge graph. So this is an example of the potential of course, annotating cybersecurity operational documentation, and especially finding the best way to respond to specific attacks given emerging conditions. This comes to the core of a concept that is much broader, the issue of cyber ops, mimicking especially the concept of DevOps, but the idea that the operational facet of cybersecurity is necessarily linked very closely to the design of its environment, the design of its operational environment, technology environment. And here, an issue that is crucial, the linking of both human and technical and operational factors together. In the red circles, you can see the importance of patterns and automation, as well as rules in that context for operations. And on the other hand, of course, cognition and the capacity of a team to comprehend the situation that they are facing as, of course, a cybersecurity incident progresses. This comes to the question, therefore, what is the potential for cybersecurity automation that will include both, of course, operational and information-based decision-making, as well as human and team-based decision-making together, which is basically the concept of automation with humans in the loop. This is why a major research effort must be made to properly configure intelligent cybersecurity systems with situational awareness. The concept of situational awareness is a fairly simplistic problem. It's the issue of merely gathering information and perceiving and understanding the state of the world, basically what is happening at every point in time. And of course, because there is divergence from understanding and facts, this awareness fluctuates throughout an event or an attack. The concept of awareness is also linked to a team's capability to learn from its own, of course, mistakes, but also from the mistakes of others and also from their successes. And comes to this fundamental issue of, can we represent that learning beyond the basic representations that we know today, which are cybersecurity defense protocols, as well as the knowledge graph we just mentioned earlier. Those representations are, of course, limited, but they represent an opportunity to automate decision-making. So the challenge in doing this research is actually to carefully study to what extent can we mimic human teams' capabilities, automate what we can automate, and ensure that the non-automated part can be effectively used by their user teams. This also links cybersecurity situational awareness to the broader environment within which cybersecurity automation happens. Here is a very brief description of the idea that the rules that are implemented and are meshed within the cybersecurity team processes must be carefully positioned according to these 5 areas of action. And you may, of course, immediately notice that the more traditional operational facet of the automation features are found very often at the core or at the infrastructure level, and are very often linked to external assets that we can see here on the right hand. But the core challenge remains that the core tasks in the center of this design here remain to be discovered and properly calibrated. And many organizations are still experimenting with these techniques. So this is an area of research that is very current. So we encourage you, of course, to read more on this research, and naturally, we invite you to contact us if in any case you're interested in performing such a partnership. Thank you.
I'm Marc Andre, postdoctoral fellow at École Polytechnique in Montreal. I'm also a lecturer at the John Molson School of Business at Concordia and at the University of Sherbrooke. I'm presenting today a part of a research that was developed with Professor Gagnon and his research team as part of my PhD at the Université du Québec in Outaouais. The cybersecurity competency ontology that we developed can be replicated in a 6-step process that we've documented here. The first step is to gather all the data, for example, from research articles, publications, but also internal documents within the organization. Then we collect and integrate all of the data into a meta model. In step 3, we then hold a series of workshops with the different cybersecurity teams within the organization, including managers. In step 4, we then integrate all of this material into the ontology. So we start building the ontology as we're collecting all of this data. We add to that in step 5 data that was collected through web scraping, and going through job postings and different job ads that were made by the organization over the last few years. Then, of course, integrating that in step 6 into growing and maintaining the ontology. So what you're seeing here on the right is basically a representation of what the model looks like of competency in cybersecurity, which is made of knowledge, know-how, know what, and know how to be, and going further into greater levels of detail. So when you look at it from a graphical database point of view, this is what it looks like. So you have actors who have roles in the organization. To these roles correspond a certain number of tasks. And for each task, you need certain competencies to be able to successfully accomplish this task. Competencies can be further broken down into academic competencies, functional competencies, technical competencies, workplace competencies, and then know how to be also referred to as soft skills. So that's often a neglected area for which in cybersecurity plays a very important role, as it does in other sectors as well. So once we've defined this model, once we've created this model, we can develop different tools using the ontology. And so one of the tools that was developed as a proof of concept in our project was a dashboard. And what you're seeing here is part of the dashboard, where through a questionnaire and an evaluation process, we can determine the level of competency for people in a cybersecurity team based on different actual competency elements. So you see those here reflected by the code assigned to each of those, and we're only showing you a few of those. The global, if we look at every single competency, obviously for a work role, they could be many depending on the role. So here what we're seeing is what's the average, the median, the 50% centile where all the values are, the low values, the high values. So this is helping us to determine for the different work roles what is our current status. And we can even go further by looking at using the ontology into specific competencies and comparing the actual level or current level of competency of a actor in a role, and then looking at, okay, what are the requirements for this person? So where should they be? And identify the gaps, and you can see them here with the yellow arrows. But also at the same time, you could use this to help fill a vacancy in the organization. What is suggested is by taking a more junior person and upskilling them into a more senior role and then hiring at a lower role. This could also be automated, looking at CVs or looking at job postings or looking at individuals in non-traditional roles to evaluate how they could fit within the certain roles of your evaluation, or even through a succession planning type. The next step of this, and what we're currently working on, is to integrate this into more of an AI, or if you prefer machine learning or semi-supervised learning strategy, where this can actually be completely automated. And so that is what the system, the next evolution of this research project is looking at right now. Thank you.